How's it going, everybody? Welcome back to Practical Network Fundamentals. In this video, we are going to be doing routing, but in real life. As you can see here behind me, I have a whole stack of older networking equipment that I'm going to be using to demonstrate to you how routing works in a real-world network environment. Now, what you're going to want to consider when you're setting this up, and you could consider this a capstone lab. I'm going to walk you through all of this and how to do it. What you want to consider first is that you have to connect to these devices somehow. And we did cover Cisco IOS a little bit in the last video, but in this video, I want to show you practically, because when you do it in Packet Tracer, it's just a little blue line that you drag into the topology and bam, it works. When you do it for the first time in real life, you start to see that there's some things that are quite different. For example, this cable that I have right here is a USB to serial cable. And what it lets me do is connect console cables that use this traditional RS, 232 connector type to connect to a traditional console port. And you will want to have one of these in your bag or your toolkit, whatever you want to call it, wherever you go. I found this to be very handy, and I believe serial ports will never die, as someone once said in a live stream of mine. And we're going to connect this, and it's going to allow us to connect into Cisco IOS. But there's going to be a few steps that we want to follow in that process. So the first thing you want to do, of course, is get a USB to serial connection. You can get those from Amazon. You can get those from Staples. I'll put some links below so that you can find that easily. And you'll want a console cable. Thank you for the follow. And a console cable is going to look something like this. And they do have console cables that are RS-232, and they also have console cables that are USB only. So they go USB from your laptop to USB to the device. But you may want both, because you may come across devices that they don't have, like routers and switches that do not have USB only for console, right? They have this connector type. Right, looks like an Ethernet cable. So I'm going to connect it in right here to the console port. And what I'm going to do in Windows is I'm going to open up Putty, and you should see that pop up on your screen soon. I'm going to open up Putty, and I'm going to connect to the router's Cisco IOS, the command line interface, through Putty, which is a terminal emulator. This is another thing you'll miss by just doing Packet Tracer. So I've got Putty open here. I want to show you how you're going to do this from scratch. So you're making all your connections. You're going to open up Putty. And in Putty, what you'll see is the option for serial. That is not Captain Crunch. That is, a connection type. And we're going to pick a certain COM port. Now, traditionally, the default COM port is COM1. And that's for computers that have a console port on them, right? And that is, for the most part, not a thing anymore. I do like that big old, technician's laptop that has all the ports you want, but we now live in the age of USB ports, and some laptops are going away from having ports at all. So it's becoming a challenge when interacting with some of these types of devices. But, if you do have ports, get USB. But for now, no, this serial connection, that COM1 port, is going to give us issues if we try to connect, because we don't have a COM1 port. So you might be wondering, how do you find that? Like, what do you mean? How do I find what COM port my USB to serial adapter is on? And the answer is you go to Device Manager. So in Windows, you can search device, just type I'm a search person. I like to type, I like to type it out. So go to Device Manager, open that up. You're going to see, all the devices connected to your computer. And you're going to want to expand the one that says ports, COM and LPT. Expand that. This one is a prolific USB to serial adapter. If you have a different type of or different manufacturer made yours, it'll have a different name, of course. But the commonality here should be the COM. You'll see COM in some number. So I'll see COM3 there, right? So now I'm going to change this on the serial line and hit COM3, open, and this is going to open a console connection with the router. So now, how do we know we're on this router? We know if we see the router option and it's got a greater than sign. So I'm going to type EN. Let me get my mic a little bit closer here so you can hear what I'm saying. I'm going to type EN. Then I'm going to do conf T, which takes me to global config mode. Remember, we went through the basics of Cisco IOS in the last video. And then I'm going to give this router IP addresses on different interfaces. But the one thing we need to be mindful of is which interfaces we're going to use. Remember, and this is another part that's going to be very valuable for you to really get a grasp of, because when you go out there and you're troubleshooting different, different networks, or you're setting them up from scratch, one of the things that you're going to notice is, virtual and physical ports are really sort of a challenge to just imagine off the top of your head. You're going to want to know where certain LANs and certain switches are connecting to on that router. And in this case, what I'm going to do is essentially the real life version of what we did in Packet Tracer in the last video. So this Surface Book is going to be on the 192.168.0.0 network. This Mac right here is going to be on the 172.16.0.0 network, just to keep them logically separated and you can see it easily, and physically separated. So in this, we're going to have them on two different switches, right? So the first thing you'll see here is that from my Surface here, this 192.168 device, we're having the cable running from the NIC, the USB NIC, to the Cisco switch, and from the Mac, which is the 172.16 network, it's running to the Netgear switch. So you can see that those are on physically separate networks. Now I want to ask you, from a layer 1 perspective, or a physical layer perspective, what am I missing here? You could let me know in the chat, or you could let me know in the comments. What is actually missing to make the physical connections here work? Because right now I can tell you, when I look at this, it's missing something. It's not just messy. I know, judge me all you want. This is a mess, but hey, I'm doing my best here. But there is something missing. So let me know. I'll let you know now. It is the cables connecting from the switch to the router. Remember, in the network, your switch, unless it's like a multi-layer switch or a layer 3 switch, and we'll talk about those later. Those are switches that route. Unless it's one of those, you're going to need a connection that runs from your switch to the router. And, during my live stream, I was talking about this, and somebody mentioned trunk, and they're correct. When you have multiple VLANs in a network environment, which is common, you're going to want a trunk to the router, but that's going to be in a future video. We'll talk about VLANs probably in the next couple videos. But for now, I just want you to see how routing works in a network. And especially if the network has physical separation and different physical ports that or cables that are connecting to different interfaces on the router. So I've just gotten these two cables, and what I'll show you I'm going to do is from my Netgear switch, I'm going to run another cable. This is going to go from the second port on the switch to 0, 1 on the router. This is an older router, so it has fast Ethernet on the router. So we'll just go to fast Ethernet 0, 0 on the router from that 192.168 network. And we should not see any link lights because I have not configured these router ports. I said these router interfaces. And then what we're going to do is we're going to run this cable, which is from our 172.16 network. We're going to run that to our router interface. So I'll go from this cable or this port. If this had VLANs on it, we would want to make one of these ports a trunk. But for now, don't worry too much about trunks. Just have that terminology in your mind. What I'm going to do is I'm going to run this cable from the switch port to FE01. When we look at our physical topology, how things are physically connected on our network, we see one laptop that's on the 172.16 network. It connects to its own switch. And then that has the switch itself has its own connection to the router. And then this laptop, same thing. It's on the 192.168 network, and it has a connection to the Cisco switch, and the Cisco switch has a connection to the router. Now we have to go into the logical addressing part of this, and that is where IP addressing needs to happen. Just a warning, in general in the industry, it's normally like a Windows server machine that's going to be handing out IP addresses to Windows machines on a network, but you do occasionally see the router being responsible for DHCP. That next step that I really think is important is getting the IP addresses set on your router. So now what we're going to do is we are going to assign IP addresses to the interfaces on the router so that our laptops and our systems on those networks have default gateway, right? Because remember that your router interface and the IP addresses or IP addresses assigned to it will be your default gateway. So I am going to first give it a host name. As always, we want to make sure it has a host name. And then we're going to do int f00, and I'm going to do IP add 172.16.0.1 with a class C subnet. Hit enter and no shut. We want to make sure that the interface comes up. How do I know the interface is coming up? Well, I will see a link light, and the output in Putty will be, things should be changing to up, right? So you should be able to see that. Now I'm going to go into fast Ethernet 01. So I'll do int f01 and then type IP add 192.168.0.1 255.255.255.0. Then do no shut. Hit enter. And that should also come up. And as this is happening, you'll notice physically from this camera right here, you should be able to see link lights on these NICs. And that's always an indicator that things are coming up. These are all the things I like to be mindful of when I'm setting up a network or I'm troubleshooting one, is the physical connectivity and all that. And there are a little bit of differences in the way mine's set up. In a future video, I will show you how normally a rack is. When network equipment gets racked, it's just a bundle of equipment you're looking at in a server closet or a rack, and it can be hard to picture it, you know. It's very much an imaginary world of thought. I guess better to say logical world of thought to see how the network works. Because walk into a big data center and you'll just see a bunch of cables and devices and blinking lights, and it's kind of overwhelming if you don't understand topologies and how things are supposed to connect. So we've got everything's up. We have the IPs. This is where we'll want to start to try to test if we can ping our gateways from our laptops. Meaning, for example, if I'm on my laptop, the Surface, that's supposed to be the 192.168 network, I'm going to try to ping from there. So what I'll do is I'll go into Windows here, and I will assign this USB NIC I've got an IP address, just so I can try to ping. So 192.168.0.10, and then I'll assign a gateway. I'm not going to worry about DNS right now. Hit OK. Hit OK. I also like open up command prompt, IP config, make sure that setting stuck. And then I'll try to ping. So do ping 192.168.0.1. And I am able to ping 192.168.0.1, which means that my router interface for that LAN is accessible over the network. All right, so now on the Mac, which is on the 172.16.0 network, I have assigned it an IP address statically, and I'm going to try to ping the gateway from here. Remember, when you're setting up a network, anytime you're setting it up from scratch or even just finding a place to troubleshoot, I recommend starting with ping, and this is just more the mindset, starting with where are my physical connections? Are they where they need to be? What is the IP addressing? Is the IP addressing right? Does it even have an IP address? Because believe it or not, I've come into issues where, there's a network connectivity issue and the devices are not getting IPs. And it might be because DHCP is down or some other conflict preventing machines from getting an IP. But that's why I'm saying think from first principles, what should already be there. So that's where I'm kind of thinking here, and why as I build this from scratch, it's not too complicated. I know it's only 2 networks, but it's still the framework of thinking that can help you troubleshoot through things. So now what I'm doing is I'm pinging the gateway of the 172 network from the device, or the client, the 172.16.0.1, and I'm getting successful replies on the Mac. So I've got successful replies on Windows, and I've got successful replies from the Mac network. These are my 2 different networks. Now what we need to look at is the routing table. Do you remember from the last video? We did this in Packet Tracer. We looked at the routing table. How does the routing table work? How does everything, connect? How does the router know where to send packets? How does it know what to do with the destination IP address? So we're going to do that, and we're going to get into that again on Windows. So I am opening up Putty. I'm going back to my router, and I'm going do show IP route. Again, let me know in the comments, why did I type do before show IP route? I'll tell you, because when you're in global config mode, if you want to run show commands, you've got to type do. All right, so what I'm seeing on the screen here is a good sign. I'm seeing 2 different networks learned. Remember, when we look at a routing table, the codes are like the legend of a map. And it explains how we're supposed to read the routing table. So when I see a C, I see connected. When I see L, I see local. And that means I have both of these networks are directly connected. So if I was remoted into this network right now and I wasn't physically standing in front of it like I am right now, you would, I would have to do show IP route to understand what the topology looks like, the logical topology, the IP addressing, what can connect to what and where, right? And how do things get where they need to go? I will go to the routing table and I will look and see. And this is what I would see, and I would think this is a good thing, especially if my goal is to be able to ping but from one to the other. So that's what I'm going to try to do. And the way we do that is we make sure we know the IP address that we've assigned to both, and we will try to ping each of them over the network. Okay, so all right, so now what we need to do, now that both of these networks can get to their gateway and both of these systems can get to their respective gateway, is we want to make sure that we can ping each computer. And the way that I check that first is I'm going to go to that router and I'm going to look at the routing table. So I'm going to do, from global config mode, I'm going to do the command do show IP route. You can see I did it there before. And it's going to show me my routes, right? Remember, when you see a C and an L in the routing table, you're seeing connected and you're seeing local. And that means that these networks are directly connected. So this is a good sign. In my mind, if I'm troubleshooting some type of networking issue between 2 networks, in real life, I am going to think, okay, so the router is not the problem. At least looking at this, all things considered. So if there was an issue, the issue would either lie on a switch or it would lie on the laptops or the OS, if you will, the desktop OS level. So you really want to troubleshoot at different steps so that you can isolate the issue. But in this case, we're just building from scratch and we're just testing it as we go. But this is the benefit, and I can go on a rant, sorry, but this is the benefit of having like physical equipment, is because it'll reflect the real world, and you'll be able to at home practice with things and run in and mess things up and run into things that you might actually run into in real life, and that way when you get out there and you run into that, at least you know the next thing you need to do. And that's the biggest thing for me, is you don't have to know everything. You should just know what you need to try next. All that to say, we're going to try to ping between the Windows machine and the Mac machine. Or MacOS. So I'm going to go ahead and try to ping 172.16.0.10, which is the Mac, from 192.168.0.10. So I'll do ping 172.16.0.10. And it's not immediately responding, but that might not mean it can't get there. It might just mean the firewall in Windows is preventing a reply from getting here. So one way we could check that is we could also do traceroute. I think it's traceroute or traceRT in Windows to 172.16.0.10. And we could see where that traffic stops in its way to getting there. So we've got the pinging working between the 2 networks. This was network This was network routing in real life. Let me know if you thought this was helpful. Let me know if you want to try this at home. Reach out to me if you need help, if you are trying this at home. I hope you really enjoyed the video, and I will see you in the next one.